In this practice, we're going to be doing polygon practice. So this one says, in a square ABCD, which is not pictured, CD is 3, what is the length of the diagonal? So in a square, all the sides are the same. So I'm going to label A, B, C, D, and it says that CD is 3, which is a side, and so that one's going to be 3. Now the diagonal is going to go through here, so remember this is 90 degrees, so we're trying to find the length of the hypotenuse. Whenever you cut a square in half, you technically have a 45, 45, 90 triangle. So to do this problem, I'm going to draw the triangle out. I know it's 45, 45, 90 because the sides are the same. So its hypotenuse equals the leg times the square root of 2. Well, the leg measurement is 3. So the hypotenuse is, wrong place for the 3. There you go. So the hypotenuse is just 3 square root of 2. Now you could do Pythagorean theorem too. You would actually end up with 9 plus 9. So you get the square root of 18, which does simplify to 3 square roots of 2. I almost did it again. So you can do Pythagorean theorem or the 45, 45, 90, completely up to you. So the correct answer here is option A. Number 2, KLMN is a rhombus. So before we start anything, rhombus, remember all the sides are equal. And then KLM, so KLM, this large angle is 80. And we want to find the measure of angle 1. So the thing about rhombus, remember the opposite angles are bisected, which means that this is going to be 40 and 40. Another property of rhombus is that the diagonals will always cross at 90-degree angles. So all of these are also 90. So what you end up with is actually just a right triangle problem. You've got the angle of 40 and 90, and you just subtract that from 180. So 180 minus 90 plus 40, which is 130. So your answer is 50. So this angle is 50. So the rhombus property you need here is that the vertex angles are bisected. So these two are the same. And then the diagonals cross at 90. And the clue here is that it's a rhombus. So that's the properties that you need. All right, number 3 is about parallelogram. So in the figure, what is the value of x? So the thing about parallelograms, remember the opposite angles are the same. So this angle L has to add up to 125 degrees because they're opposite angles. Now, what I see in this problem, I see a right triangle, and that should help me know, hey, right triangles add up to 180. So 90 plus 20 is 110. So 180 minus 110 is 70. So it's a triangle. That's basic. Now we should see, okay, hey, these angles are supposed to add to 125. So I have 70 plus x. So what you would do here is 125 minus 70 to get 55. So x is 55 because together those have to add to equal 125. So the correct answer is B. All right, move my magnet. Scroll on down. I think that number 4 is very tricky. So this is representing a square, and I'm going to try my best. This one does only have 4 answer choices. So I'm going to draw the square up here just to kind of help us. The one thing we should know about a square is that all the sides on a square are equal. So these two values are representing the sides. So what we're going to do here, we do need perimeter. But before we can start there, we do have to know what x is. So I know that the sides are equal, so I'm going to do x squared plus 8x equals 5x plus 28. So what I would do, I see a squared value and I see x and I see a constant. My mind should go to factoring. So I'm going to move everything over here, giving me 8x, or excuse me, x squared. 8x minus 5x is 3x, and then subtracting the 28. Remember, we want to keep the x squared positive. So I'm looking for 2 numbers that multiply to negative 28, and those same 2 numbers should add to positive 3. Those numbers are 7 and 4. To determine which one's negative, I'm going to look down here. The way to keep this a positive 3 is to make the 4 the negative value. So I get x plus 7, x minus 4 equals 0. So my potential answers are negative 7 and positive 4. So now that we kind of talked about that. So to help me figure out which answer I'm going to use, if I plug x into the 5x plus 28, if I plug in negative 7, 5 times negative 7 plus 28. So 5 times 7 is 35. So negative 35 plus 28. That gives me an answer of negative 7. I cannot have a side of negative 7. So the negative is out. Like I can't have a negative side value because I'm working with a side of an actual shape. So I want to use 4. So if I plug in 5 times 4 plus 28, I get an answer of 48. So what that means is one of the sides of the triangle of the square is 48. But it's a square, so all of them are at 48. They're all the same. So to find perimeter, I'm going to add 48, 48, 48, 48. And when I add all this together, I get option D, which is 192. So I do have to factor on this problem, and the way that you tell which one is the extraneous solution is based on the sides. Remember, you can't have negative side lengths. Okay, number 5. In the figure of the quadrilateral, what is the measure of C? So this is a question mark. Remember, quadrilaterals add up to 360 degrees. So basically all of these just have to add up to 360. So I'm going to change question mark to X. So I'm going to do X plus 67 plus 85 plus 149 equals 360. So when I add all those together, let me go ahead and do that real quick. 67 plus 85 plus 149 is 301. So I get X plus 301 equals 360. Subtract 301, X is going to be 59, which is answer choice C. So the way that you do these problems, you just look at the angles. All of the angles of any kind of quadrilateral will always add to equal 360 degrees. Okay, number 6, the triangle ABC. AB and BC are equal. So I'm going to go ahead, draw any kind of triangle, ABC. AB and BC are the equal ones. So this lets me know it's isosceles. Angle C is 65, and we're trying to find the measure of B. Now in this one, this triangle is actually an isosceles triangle because I have 2 congruent sides. And in your picture, the side that's not congruent to anything is the base. And the angles that sit on the base are called base angles, and those angles are the same. So this angle is also 65. So I would just do X plus 65 plus 65 equals 180. And when you solve, you end up with X being 50. So triangles always add up to 180. All right, number 7. In the parallelogram, it says QS is perpendicular to ST. So QS, ST, that lets me know that this is 90. And then QSR is 25, which is drawn. What is the measure of QTS, which is drawn here? So in this figure, this is a parallelogram. What we know about parallelograms is that the opposite sides are congruent. And this particular parallelogram actually ends up being a rectangle. So anytime we're dealing with parallelograms, we've got the 90 degree. This is a rectangle, which will also let you know that all of these diagonals are the same. And what that ends up creating is an isosceles triangle. Just like the one above, it's basically the same thing. So I should see an isosceles triangle. So to calculate this measure, I'm going to do 90 minus 25. So 90 minus 25 is 65. And since that this triangle is isosceles, these 2 are the base angles, creating this one as also being 65. So to kind of help you see the same image from here, these are the 2 equal legs. This would be the base. The angles that sit on the base are base angles. Number 8, rectangle has measurements 8 and 4. What is the measure of the diagonal? So I'm going to draw my rectangle. One length is 4 and one is 8, and we're trying to calculate the length of the diagonal. So that's just Pythagorean theorem. 4 squared plus 8 squared is c squared. So we end up with the square root of 80, which is not a choice. We have 80 as an answer, but that's because you don't square root to get that answer, so that's bad. So when we simplify, the square root of 80 is actually broken up into 16 times 5. The square root of 16 is 4, leaving us with the square root of 5, which is option D. All right, number 9, in the angles below, the triangle measurements are 3x, x plus 10, and 2x minus 40. What is the size of the smallest angle? So first, this is a triangle. So 3x plus x plus 10 plus 2x minus 40 has to add up to 180. So when I combine all those like terms, I get 6x minus 30 equals 180. So my x answer, I'm going to add 3 to get 210, divide by 6 to get 35. So x is 35. However, that's not my answer. It wants to know, excuse me, it wants to know what value is the smallest. So I'm just going to plug it in. So I have 3 angles here. So 3 times 35 gives me an answer of 105. Then I have 35 plus 10, which is 45. And then I have 2 times 35 minus 40, which gives me an answer of 30. So 30 is my smallest angle, which is option A. Okay, what is the maximum number of diagonals that can be drawn below? So the way that you do this is you just count. A diagonal goes from one vertex to another, but it does not count as a side. So if I start here, I'm going to have 1, 2, 3. Distinct means that it will not repeat. So when I go down here, I'm going to go 3, that's 4, 5, 6. When I hop over here, I am not going to count this one because I already drew it. So 6, 7, 8. Then as I hop around to go here, if I'm connecting, those lines have basically already been drawn. So I'm at 8 right now, but this one I can draw here. So that's 9. Then hopping over here, connect, connect, connect. Those are already drawn. And then again over here, those are already drawn. So we are left with 9 non-overlapping diagonals. So a diagonal connects one vertex to another, but does not count as a side. And distinct means that they don't overlap. All right, next up, we got number 11. Oh, number 11 we skipped. The reason we skipped number 11 is because the correct answer actually is not there. All right, number 12, what angles appear to be obtuse? So this picture is basically just you looking at the picture and saying, okay, what angles look like they're bigger than 90? Well, 2 and 4 look littler. They look less than 90. So the ones I'm left with are 1, 3, and 5. So angle 1 looks bigger than 90, 3 looks bigger than 90, and so does 1. So that was just based on looks. All right, what angles are vertical angles? Vertical angles are across from each other, so the correct answer would be 1 and 4, and I see that is an answer. You could have also chosen 2 and 3. However, 2 and 3 is not an option, so that's why the correct answer is D. 2 and 3 are still vertical, it's just not an answer choice. All right, at how many points will 2 lines that are perpendicular intersect? Well, let's draw them. So perpendicular, they cross at 90. So here is 1, and here is another, and they cross at 1 point. So that's it. Just sketching a little picture will actually make that a little bit easier. Number 15, the sum of the interior angles of a pentagon. What I want to do here, a pentagon has 5 sides. So I would do 5 minus 2 times 180. Remember the polygon angle sum theorem, which is, I'll write it down here, n minus 2, and represents the number of sides. 5 minus 2 is 3. 3 times 180 is 540. So you could either use the theorem or just kind of memorize that a pentagon will always add up to 540 degrees. All right, 16, what is the measure of the smaller angle below? Well, these are a linear pair, which means they should be adding up to 180. So I'm going to do 15x plus 50 plus 12x minus 5 equals 180. Combining like terms, 15 and 12 is 27x, and then 50 minus 5 is 45. So when I subtract 45, I get 135. And when I divide 135 by 27, I get 5. So I'm going to plug these in. So 12 times 5 is 60, minus 5 is 55. Well, this one is definitely over 55. So 180 minus 55, this one would be 125, which is an answer, and this one's an answer, but it wants to know the smaller angle. So the smaller angle is A. All right, number 17. In the figure, A, B, and C are perpendicular with A and B being perpendicular. So A crossing B, that means these are all 90 because they're perpendicular. What angles are congruent? Well, based on this picture, 2 and 5, they're both 90. So the answer is D. So we don't know if any of the other angles are the same, but we do know that 2 and 5 are in fact equal. Number 18, PRQ forms a straight line. That lets you know that you have a linear pair. Find the measure of W. So these three angles will add up to 180. So 2W plus W plus 30 has to equal 180. So 3W plus 30. Subtracting 30, I get 3W equals 150. Dividing by 3, W is 50. So that is the answer, 50. So linear pairs add up to 180. Again, those are visual vocabulary words. You have to look at them. You have to know what they are. Okay, 19 is not multiple choice, but it says that CDB is 60. What is the measure of CDA? Again, this is a linear pair and it adds up to 180. So I would just do 180 minus 60 to get an answer of 120. That's just a linear pair. And it's telling you it's a straight line, so you know that it is, in fact, 180. All right, last page. Hopefully these are getting a little bit easier as you go. All right, we're looking for which side lengths do not form a triangle. So remember, to form a triangle, you must add the two smallest sides, and they must be greater than the largest. So 1 plus 1 is 2. 1 plus 1 has to be greater than 1, and it is. So it's not A. We're looking for the ones that don't work. Now, if you're glancing at these, hopefully you recognize a 3, 4, 5. That's a right triangle. So D is out. Do not cross out 30, 60, 90. Those are angle measures. Those angle measures do make a triangle, but side lengths, remember, we're going to be adding. So if I add 30 plus 60, is that greater than 90? No, it's equal to 90. So that is the correct answer. And they purposefully choose those numbers because you see 30, 60, 90 and you're like, oh, that's definitely a triangle. But in this case, they're side measurements. They're not angle measures. So be careful. 21, in the quadrilateral, the measure of A, B, and C are 35, 60, and 35. So A is first, which means the first one goes with A. So 35. Oh, not 350. 35. The measure of B is 160. And then C is also 35. What is the measure of D? So this is a quadrilateral. It has 4 sides, so that should let us know, hey, it adds up to 360. So I'm going to do X plus 35 plus 160 plus 35 equals 360. When you break it down and solve for X, you end up with an answer of 130, which is B. All quadrilaterals add to 360. All right. The length of the side of a square is 4 square root of 2. So I'm going to draw a square. Okay. The square, I'll continue the square, sorry. The square has side lengths of 4 square root of 2. So this is 4 root 2, 4 square root of 2. We're trying to find the length of the diagonal. So again, this is a special right triangle. So its hypotenuse equals the leg times the square root of 2. So the leg is 4 square roots of 2 times the square root of 2. This will end up equaling 4 times the square root of 2 times the square root of 2 is just 2. So the hypotenuse is 8. Anytime you're dealing with squares, you'll always have 45, 45, 90 triangles. And they really like those problems. You can use trig. You could also use Pythagorean theorem, but they take a lot longer than just memorizing and using the special right triangle formulas. All right, number 23. What is the length of the side of a square with a diagonal of 5 square root of 2? Well, I'm going to draw another square. Okay. The diagonal in this case is 5 square root of 2. We're trying to find the length of the side, which is the legs. So in this problem, the hypotenuse, again, equals the leg times the square root of 2. So 5 square root of 2 equals the leg times the square root of 2. You can divide by the square root of 2, and since you have that on both sides, they both cancel. So the leg measurement is just 5. Again, you could use Pythagorean theorem if you wanted to. I would recommend special right triangles because they just make life easier. Speaking of special right triangles, number 24 is also special right triangles. It wants to know the length of the hypotenuse. Well, this side is h because it's across the 90, across the 30 is short leg. So your formula is hypotenuse equals the short leg times 2. So the short leg is 10. So 10 times 2 is 20. So your hypotenuse is 20. Special right triangles are a great tool. I recommend using them. You could use trig if you really wanted to, but again, it's just easier to use special right triangles and just have the formulas memorized. But you could do trig. I mean, you could do opposite over hypotenuse. So you could do the sine of 30 equals 10 over x and solve. But I think special right triangles are a lot faster. 25, what is the name of the polygon whose sum of the interior angles is 1080? So we're looking for the number of sides. So the way you set this up is n minus 2 times 180 equals 1080. So the first thing you want to do is divide both sides by 180. So you will get n minus 2 and then 1080 divided by 180 is 6. And then you have to add 2. So n is equal to 8, and an 8-sided figure is called an octagon. Chances are, be very careful. If you don't add 8, you would pick an answer with 6. Or if you don't add 2, you would pick 6. So just be very careful. All right, 26. If two sides of a right triangle have the lengths 2 and square root of 2, which of the following lengths could be the third side? So option 1, 1 square root of 2. Well, the square root of 2 is the largest. So if we're going to do to test if it's a right triangle, the Pythagorean theorem has to work. So what we're going to do here is we've got 1 squared plus 1 squared has to equal the square root of 2 squared. Well, 1 plus 1 equals 2. So that one works. So 1 is an answer choice. The Pythagorean theorem was true. Next, we've got 1 square root of 2 and 2. Remember, the square root of 2 is 1.4. So that would make this the hypotenuse length. So we would do 1 plus the square root of 2 squared equals 2 squared. So 1 plus 2 equals 4. Well, that's not true. So 2 is not an answer. So anything with 2 in there, those are out. It can't be only 3 because obviously 1 works. So we have to test option 3. 1 squared plus the square root of 2 squared equals 3 squared. Well, 1 plus 2 has to equal 9. Again, not true. So only option 1 works. So all you would do is just use the Pythagorean theorem. 27, in the figure below, what is the length of the side of the square? Things to remember, the sides of the square are all the same. Also, things to remember, 3, 4, 5 triangle. Right here, this is a 3, 4, and 5 triangle. So the answer is just 5. All the sides are the same, so it doesn't matter what side I find, all of these sides are 5. And that's just special right triangles. And last one, sine of x is 1/2. What is tangent of x? So the sine is opposite over hypotenuse. opposite over hypotenuse. So what I'm going to do here is draw a right triangle. I'm going to put X here. So the opposite side is 1, the hypotenuse is 2, and we're trying to calculate, oh, I probably shouldn't have used X again, so I'm going to use, I guess, Y. There we go. So what I'm going to do here is just Pythagorean theorem. 1 squared plus y squared equals 2 squared. So 1 plus y squared equals 4. Y squared equals 3. So when I square root, y is equal to the square root of 3. So if I want to do trig, the tangent of x, this would be my opposite side and this would be my adjacent side, because remember, tangent is O over A. So 1 over the square root of 3. However, not an option, so I must rationalize. So I'm going to multiply top and bottom by square root 3. So I get square root of 3 over 3, which is option C. That one is tricky. You do have to rationalize to be able to do that one correctly. That's okay. It's something that we've practiced and it's a skill that we've used. So I hope that this makes a little bit more sense after going over all of these answers. I know that polygons can be tricky, but hopefully just kind of going over all of the practice problems, it's made it a little bit easier for you.